All right, let's dive in. Today we're talking about one of my favorite tools in the Unreal Engine toolbox, Blueprint Visual Scripting. Seriously, whether you're a designer, an artist, or even a programmer who just wants to get ideas working fast, you've got to know blueprints. It is absolutely key.
So let me just start by asking you this. How do you make a game do all the cool things games do? You know, opening doors, creating complex enemy behaviors, all without typing a single semicolon or curly bracket of C++? Well, the answer is this incredible system called Blueprints. And that's what we're here to get a handle on today. It's the bridge that takes your ideas and turns them into a real, functioning game.
So here's the game plan. We're going to start with the absolute basics. What is this thing? Then we'll get into the most important distinction you need to know, level versus class blueprints. After that, we'll look at some real-world examples. I'll give you some best practices so your scripts are clean and efficient, and we'll wrap it all up with a quick review to make sure it all sticks. Okay, first things first. Before we can start building anything crazy, we have to understand our tools. Think of this part as learning the basic alphabet and grammar. You got to know the letters before you can write a story, right? So what is Blueprint, really? Well, you can think of it as a visual, node-based system. Instead of typing out code, you're visually connecting these boxes, or nodes, that represent different actions and logic. The key things to remember are visual, node-based, and no C++ needed. It's built from the ground up to be super accessible, especially for designers, and it's just unbelievably powerful for getting ideas up and running fast. Now this slide here, this is the whole shebang. Every single blueprint is made of these 5 things, so let's break it down. You've got nodes. These are your verbs, your actions, things like play a sound or move forward. Then you have pins, the little dots on the side of the nodes. Think of them like wires. The white ones are for execution. They control the flow, what happens first, then second, then third. The colored ones carry data, like a number or a player's location. Then we have variables. These are the nouns, the memory. This is where you store stuff like player health or current score. Events are the starting guns. They're what kick off a script, like when the level starts or you press the F key. And finally, functions. These are just tidy little packages of logic that you can use over and over again. Okay, everybody, lean in a bit closer for this one. I am not kidding when I say this is the most important concept for a beginner to really get right. It's where almost everyone gets tripped up at first. Understanding the difference between a level blueprint and a class blueprint is going to shape how you build your entire game. And this right here is the perfect way to think about it. A class blueprint is a recipe. It's the master plan for a chocolate cake. You write the recipe once, the ingredients, the baking instructions, and then you can use that single recipe to bake 1,000 identical cakes. A level blueprint, that's a sticky note you put on one specific cake. It's a one-time instruction like, hey, when the clock strikes midnight, light the candles on this specific cake. It only applies to that one cake in that one kitchen. So here's the breakdown. Look at the scope for both of these. A level blueprint is, well, stuck to one specific level. It's for unique things like triggering a cinematic when a player enters a certain area, or controlling a boss fight that only happens in that one room. But a class blueprint is designed to be reusable. It is the template for your player, for your enemies, for health packs, for treasure chests, anything you want to use in multiple levels or just pop into your world a bunch of times. Okay, theory's great, but it only gets you so far. Let's get our hands dirty and see how this stuff actually works. We're going to walk through 4 really common examples, 2 for each type of blueprint, so you can really see the logic in action. Here we go. A classic level blueprint example, an automatic door. The logic is tied to this specific door in this specific level. It all starts with an event, actor begin overlap. When your character steps into its trigger volume, boom, that event fires. It kicks off a timeline that smoothly animates the door opening. And when you walk away, the actor end overlap event fires, and it just plays that same animation in reverse. Simple, clean, and totally level specific. And here's another perfect job for a level blueprint. Let's say we want to flip a specific light switch in our scene. Now for this to work, the script has to remember the light's current state. Is it on or is it off? And for that, we use a super simple Boolean variable. It's just a basic true or false switch. We'll call it isLightOn. So let's trace the logic. The instant the F key gets pressed, we hit a branch node. A branch is just a fork in the road, a simple if this, then that question. It looks at our isLightOn variable. If the variable is true, it follows one path. Set the light's intensity to 0 and flip our variable to false. But if it's false, it goes down the other path. Crank the intensity up and flip the variable to true.
This little toggle pattern is something you will use constantly in game development.
Okay, time to switch gears to class blueprints. A health pack is the perfect example here, right? Because you're going to want to sprinkle these things all over your game. The logic is totally self-contained inside the health pack's own blueprint. So when anything touches it, it immediately asks the question using a cast2 node. It's basically saying, hey, the thing that just touched me, was it the player? If that check succeeds, it tells the player to heal up, and then it destroys itself. Boof, gone. Ready to be used again and again.
And for our last example, a continuously rotating platform. This uses the event tick. Now this event is special because it runs on every single frame of the game. So 60 times a second, it's grabbing the platform's current rotation, adding a tiny little bit to it, and then setting that as the new rotation. But here's the pro tip. See that delta seconds pin? We multiply our rotation speed by that number. Why? It makes the movement smooth and consistent, whether on a super fast gaming rig or an older machine. It makes the rotation independent of the frame rate, which is absolutely crucial for good game feel.
So, knowing how to make something work is one thing, but knowing how to make it work well, that's a whole different level. This part is all about building good habits that separate messy, slow blueprints from the clean, professional, and optimized ones. First up, organization. And I know, it sounds boring, but trust me on this, when you come back to your project 6 months from now trying to fix a bug, you will be so glad you did this. Use comments, explain why you did something complicated, and please give your variables clear names like player health, not just H or PH. Think of your future self as another person on your team. Make it easy for them. And here's a big one. If you ever find yourself copying and pasting the same chunk of nodes over and over, stop. That's a huge red flag telling you to turn that logic into a reusable function. It cleans everything up.
Now, let's talk performance, because this is huge. Remember event tick? It runs every single frame. Putting heavy, complicated math in there is the #1 reason beginner projects run poorly. If something doesn't need to be checked 60 times a second, just don't do it there. Use a timer or another event instead. And for finding bugs, your new best friend is the print string node. It literally prints the value of any variable right onto your screen while you play. It's like a window into your script's brain, letting you see exactly what's going on.
All right, deep breath. Let's pull everything together that we've just learned. This is your final review, the highlight reel. We're going to boil it all down to the absolute must-know stuff. You can think of this little table as your ultimate cheat sheet. You've got your main events, begin play, which runs once at the very start, and tick, which runs constantly. You've got your core logic, branch for making decisions, and cast2 for checking what you're bumping into, and finally, your #1 utility, print string for debugging. I'm telling you, if you master just these 5 nodes, you can build an incredible amount of stuff.
And of course, we can't forget our data types. These variables are the memory of your game. You've got your basics, booleans for simple on-off switches, integers for whole numbers like ammo count, and floats for things with decimals like health from 0 to 100. Then you have more complex types, like a vector to store location in 3D space, or an object reference, which is basically a direct link to another specific actor in your level.
Okay, this is it, your final exam. Can you answer these 5 questions right now out loud? #1, what are the 2 types of blueprints? 2, when and why would you use each one? 3, name 3 of those essential nodes we just talked about. 4, give me a real-world example of using a Boolean variable. And 5, why is putting a bunch of logic in event tick so risky for performance? If you can nail all 5 of those, you have a really solid foundation to build on.
So there you have it. We've covered what blueprints are, the crucial difference between level and class. We've walked through real examples and talked about the best practices. You have the fundamental knowledge now. You have the blueprint for making your ideas come to life. So the only question that's really left is, what are you going to build?